So this is Unit 6. Unit 6 is all about polynomials. It's another type of function. Polynomial, this is a polynomial. We've already talked about that one, but that one's a special one. We called that a linear function. This is a polynomial. We've talked about this. That's a quadratic function. If you did the extra credit, we talked about cubic function. But we'll be talking about those a lot more in this chapter. So this chapter is about polynomial functions. Polynomial functions are basically, they look basically like these, right? You have a number in the front, a variable, and then a power, and that's about it. Okay, and then there's a bunch of them connected together. That's what polynomials are. So something that wouldn't be a polynomial function is something like this, because we have a number and our power is actually a variable. That's not a polynomial function. But I don't know, depending on how awesome of an Algebra 2 teacher you had last year, or how mean, however you want to define it, you may have done a lot of what we're going to do, or maybe not. We're going to learn basically things like that. This whole day should be reviewed for you. But it's an important thing to review. We're talking about factoring today. Factoring is important over there on our y, on our y house squared board. Factoring is really essential. You use it for solving polynomial equations. You use it to simplify expressions. You use it for graphing. You use it for a lot. So this is going to be something we do all year, so you want to make sure you're strong with your factoring. So that's what today is specifically. But we're also going to get into things like solving polynomial equations, graphing polynomial equations, and etc. So, what? Stepping on the rug? Oh yeah, that's okay. All right. So we're going to buzz through a lot of the first ones pretty quick. And then I want to spend most of our time on the last slide, where factoring gets a little bit more intense. So go ahead and write down example 1 here. We're talking about how to factor out a GCF. Huh? We are factoring. And the first strategy I'm going to share with you guys is factoring out a GCF. All right, so we're going to talk about, I think I listed 4 strategies for factoring on the beginning there. This is our first one. I want to make sure you guys know how to take out a greatest common factor. So what's the biggest thing that goes into 10 and 15? So we're going to take a 5 out, and when you do, you're going to divide it out. So if you, matter of fact, I think I'll show my work like this. I'm going to give myself a little bit of space. We're going to divide out a 5. So if I were to divide both of these coefficients here by 5, what would be left here? 2 here and 3 there, right? Now, this one has 5 x's to give. This one has 2 x's to give. What is the most number of x's that they're both able to give? 2 x's. You can't give more than 2, because if you tried to give more than 2, this guy would not be able to contribute. So we're going to take out 2 x's, but once again, we're going to divide that out. So in this case, they just kind of cancel each other out, right? But in this case, 5 over 2, that's going to leave us with how many x's? 3. And that's how you take out a GCF. It's like the reversal of distribution. With distribution, you multiply in, right? But with factoring out a greatest common factor, you're dividing out. Yes.
Why do you put x squared next to 5?
I put x squared next to 5 in 3 places. There.
In the answer.
Here?
Yeah.
Because that's the GCF. So let's circle that, and we'll say, okay, that's the greatest common factor. So remember, greatest means biggest, right?
Okay.
Common means what they have in common, and factor means something you're multiplying by. So since these had the greatest thing that they had in common with the variables was x squared, then I took out an x squared. The word factor, by the way, who could define factor for me? Like, not the verb, but the noun factor. Not with a phone, just with your mind. Okay, a factor is a number or an expression that can be divided into another number. So for instance, 3 can divide into 6, right? So you could say that 3 is a factor of 6. So in this way, this is a factor of both of these numbers because it can be divided into both of them. And in this case, it's the greatest common factor. We took out the biggest thing we possibly could. Okay, so that's what GCF is. Student practice time. Show me what you got. Giovanni Ramos. What did you get? Uh-huh. I'm going to leave the negative off for now, but what did you get on the inside? Uh-huh. And on the last one? Anything? Okay. So that's a common issue. So first of all, do we take out a negative or a positive? I'm glad that 2 people brought that up. Let's make a little note here. We only need to take out a negative if the front number is negative. Like if the 21 was a negative. Actually, you don't even really need to do it, but it just makes factoring for other situations easier if you do. So it's a good idea to do that. So we only need to take out a negative if the we call it the leading coefficient, the number in the front, is negative. Okay? So in this case, I'm not going to take out a negative. Now, another thing is what goes here is we're kind of tempted to put nothing here, right? Because here's what happens. I'm going to bring this down a little bit. We're dividing by 7, right? And so 7 goes into 21 3 times. X, if you take 1x out of x cubed, you're left with x squared. We're all good there. Here, what happens is people go like that, and they think it's gone. Now, when we do that in math, when you're dividing, when it crosses off, what's really left is 1. The reason for that is because you're dividing. And what do you get when you divide a number by itself? You get 1, right? You don't get 0. So now a lot of time we don't do that. Like if you had AB over CB, let's say we had that, right? And you did that. That's all we do, right? Do you see a 1 anywhere? No. But we don't do that. We don't put a 1 in this case. You know why? I mean, you would have this, right? Or maybe this. But isn't that just this? Right, so we don't bother putting it. But if you only have this, you don't want to just kill it and be like, okay, it's 0. It's 1. It's 1. It's just that usually you don't need to write the 1. Okay? But good stuff. Those were actually the 2 things I saw as I came around, and quite a few people have done that. So those were good things to talk about. So let's go ahead and proceed. So that is the GCF method. Now we're going to review how to factor trinomials. A lot of you guys have your own strategy for factoring trinomials. Use what you want. I use a box method. What I'm going to do is I'm going to pause for a second, and I want you guys to see if you can factor it. I'm just going to give you like maybe a minute or so. And if you get the answer, then you can ignore me. If you don't get the answer, then you should probably use the strategy I'm going to share with you, okay? So see if you guys can get it. Then I hope you got that answer. If you didn't, you might want to use the box. Okay, so I like the box method. And with the box method, I think of it as the opposite of multiplication. So this is what we would have gotten by multiplying 2 things together, something here and another binomial here. And our job is to figure out what the heck those things are. But this was the result. Now this number is what we got by multiplying these 2 objects together. And this number is what we got by multiplying those 2 together. This guy is kind of the pain in the butt that we need to deal with. But that's the one, that's the guy with the key. He decides, did we do it right, okay? If in the end, if we end up with that guy in the middle, then we did it right. So let's throw some ideas out there. The problem with this strategy, and what makes it so hard, is that it's not a slam dunk. Even whenever I was showing you the answer, you guys heard me say, don't take this as truth yet, because it's a guess and check process. You're not really sure until you check your answer. You guess something. If it works, awesome. If not, you try again. That's what makes this kind of a pain in the butt. So let's guess. What multiplies together to make 6x squared? 3x and 2x. Now, here's the thing. Couldn't it technically also be 6x and 1x? Right? So that's the guessing issue, right? What makes 35? 7 and 5. Now, where you put the first two, it doesn't really matter. But now that we put those, where you put that 7 and 5 matters. Because if I put the 7 up here, I'm going to be multiplying it with the 3 when I fill in this box. But if I put the 5 up here, I'm going to be multiplying it with the 3 and put it in this box. So it depends. So where you put those numbers is another guess. So not only what numbers you pick, but where you decide to put that second pair matters. So, Elijah, where should I put the 5? Top or bottom? You just pick. You're not right or wrong yet. Yeah, because it doesn't matter. We're just guessing. I wouldn't know either until I actually worked it out. Bottom? So we're going to put 5 here, and we're going to put 7 here. Now, hope you got a pencil, because a lot of times you have to erase and try again. So let's see. So if this is 7 and this is 3, we would multiply these together to go here. What's that? And I would multiply these two to go here. What would that be? Now, is there any way that I could multiply these two, or not multiply, but add, because these are my like terms. Don't you guys agree these are like terms? So we can combine those. Is there any way I can combine 10 and 21 so that I get 1? No. You can't add or subtract and get 21. Yeah. Yeah. You're right. So, now here's what I suggest. I suggest don't change your numbers yet. Instead, change where you put them, okay? So what I'm going to do is I'm going to switch the 5 and the 7. So if your first guess fails, don't change your numbers. Just switch where you put them. So I'm going to put the 5 up here and then the 7 here. If that doesn't work, then we throw it out and we start with whole new numbers. Okay, we want to try everything we can with the numbers we picked first before we move on to something else. Otherwise, you forget what you tried and it gets all confusing. So now let's try it. 3 and 5 makes 15, and 7 and 2 makes 14. Is there any way you can combine these to get 1? Yes, a positive one, right? So if I want a positive one, which one of these would I like to be negative? That 14. Now that 14 can be negative if the 7 is negative. And that actually is good, because didn't I want negative 35 to begin with? So it's negative 7 and 5. So it's always good to double check. So are we sure that this makes 6x squared? Are we sure that this makes 15? Are we sure that this makes negative 14? And are we sure that this makes negative 35? And are we sure that this makes 1? Might want to circle that and draw a little arrow. We are. Okay, then we have our answer. The answer is 2x plus 5 and 3x minus 7. So that was the biggest pain in the butt, but basically you're just trying to find the correct combination that works. And these guys tell you where to start, but this guy determines, are you right? Yeah. Yep, if you know how to do it, go for it. Yep, reverse foiling works if you know what you're doing. All right, so I'm going to throw a problem at you. See what you can do. I don't know. Let me do it. So, you guys all know this. That goes here. This goes here. You guys were working on that 2x pair, and that just wasn't working, right? So remember, when something doesn't work, first you switch the numbers, right? And if that doesn't work, you just try 2 whole different numbers. So maybe after you tried 3 and 5, you tried 1 and 15, then you switch those. That still doesn't work. Well, don't forget, you can also change the number that you guessed at first. So, and that turns out to be what happened there. We have a 4x here and x here, right? And so 3 here, 5 here, 12x, 5x, and we want -7, right? So if I want -7, which of these should be negative? Which means the 3 would be negative. And there's your answer. So it's x minus 3 and 4x plus 5. So I think you guys are a little rusty with it, but I see the skill is present. It's just you're a little bit rusty. I think what stuck most of you guys was just not realizing you had to switch your 2x's to 4 and x, 4 and 1. So let's go ahead and proceed on to our next factoring strategy. This one, I don't know. Your Algebra 2 teacher may have shown you or not, so we'll see. But go ahead and write down this one. Okay. 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 All right. What? Am I going to tell you what one of the factors are? No. We can find both. So let me show you how we do this. I'm gonna use the box again. I saw that. All right. The first one goes here in the front. The last one goes in the bottom, just like last time. Okay? But the other two go in the other two boxes. Okay? So it actually doesn't. So the other two, they can go either here or here. It doesn't matter. They're interchangeable. You'll get the same answer. For the ones with 4. Now the only issue is that sometimes with these ones it doesn't always give you the right answer, but here we go. But it either works or it doesn't. So there's no guessing and checking. It either works or it doesn't. So here's how you do it. In this case, you just look for the greatest common factor in the rows and the columns. So what's the greatest common factor here and here? I heard a few people say it. So first of all, what's the biggest thing that goes into 2 and 3? 1. You can't take out anything but a 1. What about x cubed and x squared, though? You could take out x squared, right? What about here and here? What's the biggest common factor? 3. Now, notice my 1 in the front is negative, so we are going to take out a negative in this case. So -3. What about going upwards here? They can both be divided by 2 and by x. Good. What about here? 3. I'm not going to take a negative out this time because the leading one didn't have a negative on it. Okay? Huh? Yeah. No guessing and checking on that. That works. Okay? But you should always go through and make sure it works, right? So let's see, does this times this make this? Does this times this make this? Does this times this make this? And does this times this make this? So I'm going to put here, make sure you check your work. Because it's possible that you do this and it actually doesn't turn out to work in the end. So we're working backwards the whole time by pulling things out, but make sure that if you were to put them back in, it actually works. Okay? So make sure you check your work. And this one works, so we're good. Okay? All right, so I'm going to throw one at you guys. A little bit easier. Not as bad. There you go. Okay, so that goes there. That goes there. We'll put that there. We'll put this here. All right. So I'm going to be asking. I think Aaron's here today. Let's see. How about? I don't think. Well, this is period 5. Oops. Little mistake. That's wrong. That's wrong. There we go. Haley. What'd you put here? Okay, that for me, you probably put your 5 in your spot, so I'll put it here. So here, both of these can be divided by 5 and by x. I'll take that. Kondiker, what can I put here? Okay. Jason, what can I put here? Yep. Both 15 and 9 can be divided by 3, and they both have at least 3 x's that they can donate. Nick, what can we put here? That's correct. And then finally, George, how about here? Good. Let's make sure it works though, right? So does this times this make that? Okay, we got it. Now, you may remember another strategy from your algebra teacher, okay? And I'll show you that. It's called factoring by grouping, and you're welcome to use that if you prefer. I saw Joel using it. So here's how it works. You don't have to do this if you don't want to, but you group those. Yeah? No. I'll put a plus there though, because we don't want it to make. We don't want to think we're multiplying because we're not. But I do want those. I want that negative grouped on that side, so I'm going to group them. Now, what do these have in common? Okay, what goes into 2 and 3? 1 does, right? What goes into, what can I take out of x squared and x cubed? Okay. So if I take an x squared out of both of those, what would I have left? Okay. Plus, now let's do the second pair. What can I divide out of these two? What is it? Close. Negative 3. So if I divide this by negative 3, what do I have? 2x, and here? There you go. Now, notice how these are the same, right? Now, do you see how this, what does this piece and this piece have in common? What's their greatest common factor? It's 2x plus 3. So I can factor that out. If I factor that out of here, what would be left? And if I factor that out of here, what would be left? That's called factoring by grouping. It's just another way to do the same thing. Okay, so you use whatever method you prefer. But there you go. Okay, so that's factoring by grouping. Let's talk about difference of squares. Go ahead and write down this slide, please. I think this is the best one of all. Super fast. You guys probably even remember it. So difference of squares is a special situation. It has to be a difference, meaning subtraction, of squares. Both of these have to be perfect squares. Okay? What's the square root of a squared? It's a. What's the square root of b squared? So what you're going to do is you're going to have a and b twice in 2 separate groups. One's going to be plus, one's a minus, and it factors it for you. Okay? That's the really sweet one. It just works really sweetly. So here we go. Let's do this. What is the square root of 9x to the 4th? Close. 3x squared. What's the square root of 25? Do you notice how I'm ignoring the little negative there? It doesn't matter because we're using a formula. Formulas take care of negatives for you, usually. So I got 3x squared and 5. So this is like my a, this is like my b. So my final answer is going to be 3x squared plus 5, and 3x squared minus 5. That's it. It's just a trick. It's a shortcut. You can actually use the box to do these, but it's more work than it's worth. So we're just going to use the shortcut method. Okay? You guys try this one. Bueno. And Edward, what's the square root of this guy? Kind of. Kind of.
9x.
Oh, I thought you said x squared. Sorry. All right. Joaquin, what's my final answer? There you go. Now this one's actually not factored completely, which we're going to talk about in a second. But for now, I just want to make sure you guys got the GCF method, okay? All right. Or not the GCF method, difference of squares method. So we've reviewed 4 methods for factoring polynomials. Why do we do this? Because it helps with solving, it helps with simplifying, it helps with graphing. So if you guys, so here's my warning. I feel ignored as a teacher a lot of times. I warn students, but nobody seems to care. But I'll keep talking like a man. If you don't understand how to do every problem on your homework tonight, you need to go get tutoring and make sure you do, because if you don't, you will not get the rest of the chapter. We're going to do this every day. So if you don't know factoring, you're saying, I want an F on my next test, just so you know. Okay? So make sure you guys know factoring. Go ahead and write down this slide. So we've been factoring all day. You don't need to write this, but I just want you guys to watch. So if I give you guys this, what we would get if we factored it would be x plus 2x minus 2. Just as another example of difference of squares, right? We're breaking it up into 2 things that multiply together to make that, right? So let's think of numbers. We factor numbers too, like for instance, 6. 6 is 2 times 3, right? That's factoring. Just doing it with numbers, not polynomials. And just like with numbers, like say 8, if you factor 8, you get 4 and 2, right? But sometimes you have to keep going. The same thing can happen with polynomials. Sometimes you have to factor a few times to get it completely done. Okay? Here's how you're going to do it. Here's the order you're going to go in. We always start by looking for a GCF first. Always take out that GCF. It makes the rest of the problem super easy if you start by getting rid of your GCF. Makes the numbers smaller, etc. After you take out your GCF, if there's only 2 terms, then you need to see if it's a difference of squares. It may be or it may not be. If it's not, then you're done. If there's 3 terms, you should try the box method or reverse foiling method. But once again, it may not work. That may be a prime polynomial that doesn't actually factor. If there's 4 terms, try the box method again or the grouping method. Might want to put slash box there because I taught you with the box, but the other one I showed you was called grouping. If there's 4 terms, try that. But if it ever just fails, like if you're trying and you're trying and trying, doesn't get the answer, well, one of 2 things are happening. Either A, you're just not guessing the right numbers, or B, it doesn't actually factor. And the only way you can know which it is based on how confident you are with this stuff. So let's go ahead and do one where we have to factor more than once. So would you guys please write this one down? Notice the instructions say factor completely. When it says that, chances are you're not going to be factoring just once. You're going to have to do a few things to get it done. What did I say you always have to start with? GCF. So let's do that. Is there anything that goes into 3, 9, 48, and 144? 3. I think 3 does. So let's take out a 3. That leaves 1, 3, 16. And 144. 3 goes in there 4 times 48. So we can take out a 3. How about x's? How many x's can I take out? Only 1. Because this guy has only 1 to give. So you only can take out 1 x. So if I take out 1x, what's going to be left here?
X into
X to the 6th. How about here?
4x.
Here? And then no x at all, right? Okay, so that's factoring strategy number 1. GCF. Now, after that, we go to our branch, right? GCF first, and then does it have 2, 3, or 4 terms? Does this thing have 2, 3, or 4 terms in it? It's got 4. So what method do we use?
The grouping.
The grouping or the box method. Okay? So we have x6, we have negative 48, and the other two don't matter where they go. All right, so what can I take out of these two? I agree. What can we take out of these two? No. Bigger? No. No. 7 doesn't go into 16.
8.
Bigger.
9. No.
16. And not only that, but
X.
negative 16. All right, how about this way? How about this way? So I've got this now. Am I done? Maybe, maybe not. Each of these pairs have how many terms in them? 2. So what strategy would I check? Difference of squares. Does this look like a difference of squares? It's not, for 2 reasons. One is, does 3 have a nice square root? And is it minus? Can't do it. How about this one? Yeah, that's a difference of squares. So let's keep going. Let me show you. So this guy's going to get split up. What's the square root of that? Square root of that? 1's plus, 1's minus. Are we done? Maybe. Let's check. 2 terms. Is that a difference of squares? Nope, it's not minus. Is that a difference of squares? Sure is. What's it break up into? Now we're done. Because this is not a difference. We've already said this is not a difference of squares, that's not a difference of squares, and these are not squares anymore. So we're done. So sometimes you got to keep going. So you always start by looking for your GCF. And then based on whether it has 3 terms, 2 terms, or 4 terms, you're going to use one of the strategies we've already talked about today. Okay? Well, that would be nice, but I think we're just about out of time. But I will put up a student practice for you, for anybody that wants to try their hand. Well, it's going to be on your homework anyway, so I'm going to say no to the extra credit, but there you go.